So last time we talked all about data. So we talked about how data is organized in a data set. We talked about variables that we're collecting on the cases. We said there's two types of variables, categorical and quantitative. And we're collecting that on the cases, which are individuals that we're collecting data on. And today we're going to kind of talk about, well, where did that data come from, or how do we collect data? And one way that we do that is by sampling from a population. All right, so first we're going to start with more terminology. So there's a lot of definitions in this first section that we have here. All right, so our first definition for today is going to be population. Okay, the population is the entire group of interest. So it's everybody we want to draw conclusions about. So it's the entire group of interest, and it's everybody that we want to draw conclusions about. All right, so the population is everybody we want to draw conclusions about. The sample is going to be the subset of the population that we actually measure. So typically populations are big. They're like everybody in the United States, or it even could be like all students at ACC or something like that. Those are like giant groups of people. So it would be really infeasible to talk to all of those people. So instead, we're going to take a sample. So the sample is the subset of the population that we actually measure. Okay, so the sample is the subset of the population that we actually measure. So these are the people that we actually collect the information on. Our data set is made up of the people in our sample. And then our goal is going to be to use the information in our sample to draw conclusions about the population. So we call that statistical inference. So statistical inference is using sample data to draw conclusions about a larger population. Okay, so statistical inference using sample data to draw conclusions about a larger population. So obviously, if we're using our sample to draw conclusions about the population, then it's going to be really important that we use a good method to draw our sample from the population. We want to make sure that that sample is going to be kind of like a mini population. So it's going to accurately reflect the entire population. So this method that we use to select the sample from the population is what we call the sample design, or the sampling design. So the sample design is the method used to select the sample from the population. All right, and we're going to talk about some good sample designs and bad sample designs, and we're going to talk about what makes the good ones good and what makes the bad ones bad. So just going to, looks like people are still writing. I'll give you a couple more minutes to write everything down there, and we'll look at a couple of examples. Thank you, most of you, for having your camera on. I appreciate that. All right, so, okay, so I'm going to clear this, move on to the next slide. So so this is the big picture. This is just what we talked about. We have this population. The population's big. We want to draw conclusions about the population. And in order to do that, we are going to take a sample, just a subset of the population. So the way that we take our sample from the population, that's called our sample design. We are sampling when we do that. And then when we use that sample to draw conclusions about the population, we call that statistical inference. All right, so here is a question, and I'm going to pull up a Zoom poll for you to answer this one. So thinking about yourself, which of the following is most important to you? So I launched a Zoom poll, so you should be able to answer A, B, C, D, or E in the Zoom poll. Okay, do you think athletics, academics, social life, community service, or other is the most important? All right, great. So I'll show you what we got going on here. Here's the results. So it looks like most people feel like academics is the most important, and then second most would be community service. But community service, social life, and other were all pretty tightly close together, and athletics was really low for you guys. So that's what we get when we look at our class. Now, suppose that researchers are studying student life and they use the results of our poll that we just took, our Zoom poll, not our clicker question poll, to investigate what students find important, okay? So what would be their sample if they did that? So you can type in the chat window, what do you think the sample would be for these researchers if they use the poll that we just did? Yeah, exactly. Okay, so the students in our class would be their sample. That would be the people that they actually measured. Okay, what do you think is their intended population? Okay, yeah, all students probably, unless they're looking specifically at ACC, then it would be all ACC students. So do you think that we could generalize the results of our class to the population of all students? Do you think you guys are representative of all students or even all ACC students? No. Okay, why not? Oh, Will said we're way better looking. I like that response. Okay, so why don't you think you guys represent all students? I mean, you're just one class, but we typically use like a small sample size to represent a large population. And, you know, I didn't specifically choose you guys to be in this class, right? So don't you think you're kind of a random sample? Ah, okay. So math students are a particular type, maybe. And like first of all, looking at the breakdown of our class, you probably noticed that we have a lot of females in our class and a lot less on the male side. We're probably like 3/4 females and a quarter male maybe. So right there, like the male-female ratio isn't exactly the same. Also, a lot of you guys are in like nursing, health degrees. Some people are in psychology. So we're not getting like a broad spectrum of majors. We're getting like the people that had to take this class for their major. So yeah, I don't think we're getting a true representation of all students in general if we use this poll to generalize. So we're not going to be able to generalize that. So I won't be able to write any papers, get any journal articles out of that one. All right, so this was the headline in the paper. This was in 1948, and the Chicago Tribune published this article before the results of the election were counted, where it said Dewey defeats Truman, okay? And they came up with this conclusion after they did a large telephone poll which showed Dewey sweeping Truman. So they were so confident, they published their results in the paper before even all the ballots were tallied. But have any of you ever heard of President Dewey? No. Have you heard of President Truman? Yeah, okay, so Dewey didn't actually win the election. Truman won the election. So what went wrong with their survey? It said that they did a large telephone poll, and in their telephone poll, it was like overwhelming, like Dewey won overwhelmingly. So what's wrong with that? Ah, good. This was in 1948, and who had telephones in 1948? They did a telephone poll, and who's going to have a telephone in 1948? I mean, today, I think pretty much everybody has a cell phone, no matter like what income level you are. But back then in 1948, the people that had telephones were the wealthier people. And do you think that wealthy people have the same political opinions as less well-off people? Not in general, right? Not even today. So so definitely their poll was totally biased because they only used a telephone poll and only ended up talking to the wealthy people. And obviously they were super embarrassed when they called the election wrong back then. So this just says what we talked about when we went wrong. All right, so let's talk about some more definitions. Okay, so when the method that we use to select our sample is systematically favors certain outcomes, then we call that sampling bias. So our first term, well, first term on this slide is sampling bias. Okay, sampling bias is when the method of selecting the sample causes the sample to be different from the population. So when the method of selecting the sample causes the sample to be different from the population, sorry, that was the end of sentence. So when the method of selecting the sample causes the sample to be different from the population. So with our little in-class poll, you know, that would have sampling bias because the method that we used to select our sample, which was basically, hey, I picked the easiest people available to me, my class that I could force to take a poll, then that was biased because the way that I selected it was automatically going to make it so that it was not representative of the population. And same thing with that Dewey-Truman election. Using a telephone survey in 1948 is definitely not going to give you a representative sample. So all bad sample designs contain sampling bias. So bad sample designs contain sampling bias. Okay, so one example of a bad sample design is something that we call a voluntary response sample. Okay, so in a voluntary response sample, subjects select themselves to participate by responding to a general appeal. So subjects select themselves to participate by responding to a general appeal. So for example, you know, if you go to some website and over in the corner, there's a little poll going on, they're like, answer these questions, or even if it pops up on your screen every time you go to that website, that's going to be a voluntary response sample. If an airline sends an email to all of its customers asking them to respond, that's going to be a voluntary response sample. And the problem with voluntary response samples is that, you know, you kind of put this appeal, this broad general, hey, we want everybody to participate in our poll out there. But the people who are actually going to participate in something like this are people who have really strong opinions, either strong negative or strong positive. Like if you're only so-so and you really don't care, then you're not going to bother. So think about like a comment card at a restaurant. I mean, the comment cards, they're usually sitting there right by the door. This is a general appeal. This is sent out. All customers have the option to fill out the comment card. But who fills out the comment cards? People that had great service or people that had terrible service, right? And honestly, more often it's going to be the people who had terrible service that are like, where's that comment card? I want to fill this out and, you know, tell them what I really think about it. You can see this same type of thing if you look at Amazon. So if you look at Amazon and you check out the reviews for any item, pretty much you're going to see like a bunch of people that say, you know, 4- and 5-star reviews, hardly any 3- and 2-star reviews, and then a bunch of 1-star reviews. And that's, again, because a lot of these people, you know, if you feel compelled to go onto Amazon to rate something, it's probably because you either loved what you got or you hated what you got. So those are the people that are going to go on there. Now they're trying to get more, I guess, unbiased reviews these days by, you know, I don't know, sending free products to people and saying you can give your honest opinion on this or whatever. But at the end of the day, you know, just remember that when you're reading through those Amazon reviews. These are people who felt strongly, the people who just felt like, yeah, you know, that vacuum I got, it was okay. Like, they're not going to bother to get on. If you look at like Rate My Professor, so I don't know how many of you use Rate My Professor to figure out which teacher to sign up for. Maybe you even looked me up on there before you chose to be in this class. If you look at like my reviews, they're kind of comical because they're one way or the other. Either people thought I was the most amazing professor they ever had in their life, you should sign up today, you know, or they like hated me, like I was like the meanest, like I clearly didn't care about the students, you know, it was rotten, like never take her. Like there's not a lot of in between on Rate My Professor. It's either love or hate. So, and that's because all the people that just felt so about the class, like they didn't feel compelled to write something. So if they just thought, yeah, you know, it was fine, it's fine class. Question in the chat window, does this apply to online rating sites like Yelp? Yeah, absolutely. So definitely applies to Yelp. So all the stuff that you're seeing on there, again, you're going to get the people who felt strongly one way or the other on there that apply. So the problem with these is that they're not representative of the population. Like if you look at the reviews on Amazon, for example, you know, and it's got, I don't know, like 50% 5-star rating. You can't really say that that means that, you know, 50% of all people who bought this product think it's amazing, because it was just 50% of the people who chose to come to the site and rate it. So essentially, data that comes from a voluntary response sample, you can be like, that's interesting, but it's useless as far as generalizing to the whole population and drawing conclusions about the whole population. So yeah, there's nothing that you can generalize from a voluntary response sample. Does that mean that I don't go on Amazon and read the reviews? I still read them. I actually like to hear both ways. I like to hear what people really liked. I like to hear what people really didn't like. But I know that it's not, you know, that like the catch-all. Like I know that it's not accurately reflecting the experience of everybody who bought that product. All right. Moving on. Because it takes me so long to put we just talked about this. So sampling bias occurs when the method of selecting the sample causes the sample to differ from the population. And this is what we just said at the end. I didn't write this down on the last one, so if you wanted to write it down, you could write this down here. But if sampling bias exists, then we cannot trust generalizations from the sample to the population. So that's a good thing. That's a good thing to write down that I did not type on the other one. So if sampling bias exists, we cannot trust generalizations from the sample to the population. All right, so next we're going to do a little activity to see if we can do a good job of taking a random sample. So our activity is based on a quote from the movie The Princess Bride, and I did a little poll in my class that I had yesterday on who had seen The Princess Bride and what they thought of The Princess Bride, and I was actually like totally shocked. Like I couldn't believe how many people have never seen The Princess Bride. Like more than half of my class had never seen The Princess Bride. So have you seen The Princess Bride? Yes or no? You can just type in Y or N in the chat window. Okay, good. We're getting lots more part of it. Somebody watched part of it? You could stop partway through? Like Princess Bride is one of my like, oh, now we're getting all the no's on there. Is one of my favorite all-time movies. Like I can watch this movie over and over again and I laugh every time. Now I know maybe that dates me a little bit because it did come out, I don't even know what year it came out, but I remember going to see it when I was in like 6th grade or something. So that tells you how old I am. But it's a fantastic movie. And I had this little clip I was going to show you guys, but actually we kind of ran out of time in my last class. So, so I'm not going to show you the clip. Maybe I'll post it in Blackboard in case you want to watch the clip where this quote came from. Okay, so I'm going to tell you what we're going to do. I don't know how many of you printed out the worksheet that I had I sent it out in an email after class last time. It'll just make it easier if you have that. But if you don't, it's all good. We can still do this. Okay, but what we're gonna do is everybody's gonna look at this quote that came from the Princess Bride, and you are going to try to be as random as you can, and you are going to pick 5 words from this quote. All right. So if you have the paper printed out, you can just circle 5 words on it. And if you're just looking at it on my screen, then go ahead and pick 5 words that you think are kind of representative of this quote. And what we're looking for is the average word length. Okay, so you're going to pick 5 words, write down those words, and then you're going to count how many letters are in each of those words. So I'm going to give you a second so I can leave this up on the screen here in case you didn't have it printed out, to choose your 5 words. So just write down 5 words from this quote and then count how many letters are in each of those words. That makes sense? Oh, and somebody posted 1987 is when it came out. So, yep, I was 12 years old. Okay, did everybody get a chance to choose their 5 words? Okay, so if you've chosen your 5 words, you've written those down, you've added or figured out how many letters are in each of those words. Now I want you to find the average of those. So you're going to add up those 5 numbers that you just found and divide by 5. All right, and then what we're going to do is we're going to try to make this graph together. So let's say my average is 5.2. I would put my star there. Let's say somebody else comes along, they also got a 5.2. Stack it on top, kind of like this, okay? So in the end, if there's multiple of the same things, we want them to kind of look stacked on top of each other. Okay, so now I'm gonna clear, and now, okay, so starting from this moment, go ahead and put your average on there. Okay, great. Okay, so this is kind of what we call a dot plot, or I guess in our case, it's gonna be called a star plot because we use stars, of the average length of the words in that quote, based on our samples. All right. So now here, I'm going to tell you what the real average length of the word is. So if I took all 110 of the words that are in that quote and I computed the average word length of all those, what do you think it is? So the actual population average. I'm going to draw a line where it's at. The actual population average is 3.6. So you guys didn't do a very good job of taking were your samples representative of the whole thing? I mean, I told you guys to take a representative sample, right? I said, try to select words that you thought were representative of all the words on there. You guys just like, no, I don't like following directions. I'm not doing that. No, what happened was it turns out that humans are really, really bad at pretending to be random. Yeah, Abby posted, we chose long words because they stick out more. Absolutely, it's like human nature, your eye is drawn to those bigger words. So even though you were trying to be representative, you were trying to be some version of random, it's like pretty much impossible for humans to actually be random. Okay, so I'm gonna write down a couple of those things here. Sadly, I'm gonna have to clear off this beautiful graph, but I did take a picture of it so that I can have it around. But that's the sad part about not doing this on the board and instead doing it on Zoom. Okay, so first thing is that humans are really bad at faking randomness. Okay, so so we obviously need another way. We can't just rely on humans to just go say, oh, this looks like a good sample, because it's just not human nature to be random. We actually are ordered. So we need another way. Okay, so instead, we want to use a truly random method to select our sample. So we need to use a truly random method to select our sample. Okay, so a truly random method would not be a person going through and saying, I think you, and you. Instead, we want to rely on something that's impartial, like a computer, to randomly generate what our sample should be. All right, and we talked about sample designs before. We said bad sample designs are bad because they are biased in some way. Okay, good sample designs are good because they use a random method to select the sample. So good sample designs are good because they use a truly, I can't spell, truly random method to select the sample. All right, so we're going to talk about, well, actually, I think we're gonna go ahead and do a good sample. We're gonna try to actually use a real random method to take a sample this time instead of just ourselves trying to pick the words. Okay, so to do that, okay, what we're gonna do is we are going to open up like a browser window. Okay, so I'm gonna switch my view here. So I'm opening up, because you're gonna go to Google. So, okay, and on Google, if you just Google random number generator, then it will Google actually has a random number generator in it. Something you might not have known before today. Okay, so in Google, I'm putting in random number generator. Okay, when I do that, then it brings up this here. Okay, so I need to put in basically the number of words that I have. So my minimum, I'm going to put in 0, and the 0 will make sense in just a minute when I show you the table that we're going to look at. And the maximum is 109. Okay, so change your min to 0 and your max to 109. Look, I didn't even know this. I haven't played around with this that much. There's all these different options you can have here. You can make a spinner, you can flip a coin. Save those for another day. Okay, so I put in my min as 0 and my max is 109, and then I'm going to click on that generate button, okay, and it's going to give me a random number. Okay, so you're going to do this 5 times. So write down these 5 random numbers. Okay, so click on this generate button 5 times. Your numbers are going to be different than mine. Everybody in the class is going to have probably different numbers. Okay, so just click on that generate button 5 times to get your 5 random numbers. Okay, so write down those 5 random numbers, and then I'm going to show you what we're going to do with those random numbers to select. Those are basically the word number that we're going to use. It's like we gave every word in our quote a number, and then we're going to use that one. And to help us out, if you printed out that thing that I sent out. All right, so once you have your random numbers, then you can use this table to help you quickly figure out, which word number 75 is or whatever. Okay, so let's say that my random number was 75. Okay, if my random number was 75, then I would come to row 70 here and over to the +5 column, and whatever word is in that intersection, in this case for me it would be the word the, then I would use that word. So I'd write down the word the has 3 letters, so I write down 3. Does that make sense? Okay, if my number was 101, okay, then I would come down here to the 100 row, and then the 1 column. My word is clearly, so that has 1, 2, 3, 4, 5, 6, 1, 2, 3, yeah, 7 words. So I would use that word, and it has 7 letters. All right, so you're gonna, like I said, you had 5 random numbers. You're gonna use that to figure out which 5 words you're gonna use, and this table will help you with that. And then you're gonna calculate the average number of letters in those 5 words that you've now used a truly random method to select. Okay, so here's our new graph here. Okay, so when you get your new average, then you can go ahead and plot it with a star on this. All right, so looking at this one, did we do a little bit better job this time? Does these samples look like they're more representative of the population? Yeah. When we're taking a truly random sample from the population, if we do that lots and lots of times, that distribution of values should be centered on the real value, in this case 3.6, which we totally did the second time. So you can see that using a random number generator to select your random sample is actually random compared to you as a human just trying to do your best, not so random. All right, and this is when I do this in class, then I have everybody come up on the board. So this is just so you can see what it looked like in a previous semester. Same thing. Okay, they were nobody's ever been any better than you guys at selecting themselves a sample that they think is representative, which is not really random, versus taking an actual random sample. Then you can see that it's always a better way. All right, so let's talk about some good sample designs. So these are good sample designs. Okay, the first one, and this is the one that you're really going to have to know by name. We're going to talk about it a lot in our class, is called a simple random sample. And we talk about simple random samples so much in our class that we're even going to give it like a special acronym so that we don't even have to say that all the way out all the time. Instead, we can just say SRS. So you can say, I took an SRS, and everybody will know, oh, that means they took a simple random sample. Okay, in a simple random sample, then all samples of the same size have an equal chance of being the sample selected. So all samples of the same size have an equal chance of being the sample selected. Okay, also all individuals in the population have an equal chance of being selected. And all individuals in the population have an equal chance of being selected. Okay, so basically a simple random sample is just like drawing names from a hat. If I could somehow write down everybody's name on a piece of paper, throw them in a big old giant hat, mix them up really good, and draw names from that hat, that's essentially a simple random sample. So similar to drawing names from a hat. All right, and like I said, this is the good sample design that I'm going to expect you to know by name. So if I ask a test question or something where I say, hey, what's the specific name of the sample design used here, then you should know whether or not, you should be able to identify whether or not it's a simple random sample. Versus like the voluntary response sample that was the bad one before. There are lots of other good ways to select samples. Basically, as long as, I can't spell design and talk at the same time, D-E-S-I-G-N, there we go. There are, as long as we're using a random method to select our sample, there's other ways to use random methods to select our sample besides just a simple random sample. So some of those other designs are stratified samples, cluster samples, and maybe I should, they really are called like stratified random samples. And cluster samples, systematic. And even though some of these things have the same initials as our simple random sample, they don't get to be called SRS. When we talk about SRS, we're only talking about our simple random sample. So these are all some other examples of good sample designs, but I'm not going to expect you to be able to identify them by name in our class. But I do want you to be aware that there's others out here. So, okay, give you a chance. Let me look and see if everybody's done writing that down. Okay, so I do have a little video that I'm going to show you that kind of describes several different methods of sampling, so you can kind of understand how we could use a random method but not necessarily be a simple random sample.
In this video, my trusty assistants Cadence and Kindle will demonstrate the different methods of sampling. The most basic type of sampling is a simple random sample. Consider this population of Skittles. Taking a simple random sample, SRS for short, is equivalent to putting all the Skittles in a big bowl, mixing them up really well, and drawing from the bowl. In a simple random sample, all samples have an equal chance of being selected. Second is systematic sampling. In a systematic sample, we use a random method to select the first individual, then we sample on a fixed interval after that. If my interval was 5, I could use a dice to determine which Skittle I was going to start on. If the dice came up with the number 3, I would start with the third Skittle. Then I would sample every 5th Skittle after that. Third is stratified sampling. In a stratified sample, we first take the population and separate it into groups of like individuals called strata. This would be like sorting our Skittles into colors. Then we take a simple random sample from each strata. So we would take a simple random sample of orange, another separate simple random sample of yellow, and so on. Then we would combine all of our samples to form the complete sample. Fourth is cluster sampling. A cluster is a group of individuals. Clusters are similar to each other, but individuals in a cluster may not be similar. For the Skittles, clusters would be like fun-size bags. Fun-size bags are pretty similar to each other, but within the fun-size bag there are many different colors. With cluster sampling, we take a random sample of clusters rather than individuals. In our Skittle example, this would be like putting all the fun-size bags in a bowl and randomly selecting fun-size bags. If a cluster is selected, all individuals in that cluster would be in the final sample. Clusters are different from strata. In a strata, individuals in the strata were the same, but strata were different from each other. Clusters are the reverse. Individuals in the cluster may be different, but clusters are similar to each other. The last type of sampling is a convenience sample. In a convenience sample, no random method is used. Instead, we sample individuals who are the easiest to reach, or eat in this case. Now it's your turn. How are you going to go sample the rainbow?
All right, so that just gives you an idea of some other random methods besides the convenience one, obviously, that can be used to select a random sample. So simple random sample is not the only way to take a random sample, but it does happen to be the one that we're going to talk about the most in our class. And just in case you needed some more proof that humans are not random and that we should use a computer or something like that to generate our random sample, if you took that demographics survey last time, one of the last questions on the survey said, pick a digit from the digits 0 through 9 in a way that you feel is totally random. So all of you selected a digit that you thought was totally random from the digits 0 through 9, okay? And if you were truly random, if this was truly a random process, then there should be about the same number of people choosing 0, same number of people choosing 7, same number choosing 6, like all the numbers should be equally likely, kind of like rolling a 10-sided die or something like that. If you were to roll a 10-sided die, you would just be equally likely to land on any of the numbers. So if I was going to look at like a graph of that data, then my graph would look pretty much similar to this, where all the bars, you know, if I was to have lots of people answer my survey, then my bars should look something like this. They probably wouldn't be exactly the same height, but they would be really close, and I would have more of them. It's hard to draw on a computer, so let's just pretend like you can see the rest on there. Okay, so let's see actually what really happened with that survey. Okay, there's my little suppose. Oh, I got to get rid of my drawing. Hang on. Okay, so this is what really happened. Does this look like they're all the same height? No. In fact, we've got no zeros. We have very few 1s and 2s, very few 8s and 9s, lots of 7s, and you know, 4, 5, 6 in there. People, when they're trying to choose their own supposedly random number, just nobody ever wants to choose the end points, like the 0 and the 9. Those are always like the least chosen, because in your mind, that doesn't feel random to you, even though if you were to, like I said, roll a 10-sided die, 0 and 9 would also be equally likely to come up. So here's the results from another semester here. You can see very similar type pattern here. So the middle numbers, people like to choose those, and nobody likes to choose those end numbers. Like, look at poor one. One's never gotten chosen in this time or the last time. So, again, this is just to remind you, don't rely on yourself to choose a good representative sample. Use an actually random method to choose a sample. And from here on out, whenever I use the term random in here, we're going to assume that they used a computer generator or something like that to select the sample. We're going to assume that they did not just like close their eyes and like point at people or something like that. All right, so realities of sampling. While a random sample is ideal, it isn't always feasible. So it might be hard to get a list of the entire population, or too hard to contact people that way. Sometimes your population of interest is going to have to be altered to be something that you can actually take a sample from. But if you're the person that's doing the survey, you need to think about all these potential sources of sampling bias and then do your best to avoid them. Now, in addition to sampling bias, okay, sampling bias comes because of the sample design. It comes because of the way we are selecting our sample. So when we talk about sampling bias, we're referring to bias in the method that we are using to select our sample. There are other forms of bias that can happen when we do samples, take surveys, things like that. One example of that would be like wording bias. So depending on how we word the questions, the context of the questions. If you ask some questions, you might already just expect that people are going to lie to you or give you inaccurate responses, and lots of other things. So you have to really think about that as the researchers and ask, could this potentially lead to bias? So here's a couple of question wording examples. So in one poll, they asked people, do you think the US should allow public speeches against democracy? 21% said that they should be allowed. But when they worded it, do you think the US should not forbid public speeches against democracy? 39% said speeches should not be forbidden. So opposite result just by switching allow to not forbid. Here's another one. A random sample was asked, should there be a tax cut or should money be used to fund new government programs? 60% of the people said they wanted the tax cut, but when they worded it as should there be a tax cut or should money be spent on programs for education, the environment, healthcare, crime fighting, and military defense, only 22% wanted the tax cut. So again, it's essentially the same question, but the way that they worded the question ended up producing some bias, and they got completely different results. Thinking about inaccurate responses, in a study on US students, 93% of the sample said they were in the top half of the sample regarding driving skill. Now, in order, only half the people can really be in the top half, right? Not 93%, so you're not gonna get very accurate responses there. And then from a random sample of all US college students, 22.7% reported using illicit drugs. Do you think people are going to be honest when they're asked if they use illicit drugs? I don't think so. So I think anytime you ask sensitive questions like that, or where people might be worried if they give a certain response, if you ask people if they cheated on their taxes or something like that, you're probably going to get people lying to you. So you need to take that into account and realize that you're going to have bias in your survey. So really, this is just, if you do your own survey, you need to think about these things. And if you're reading about somebody else's study that was done, ask questions, find out how did they ask the question, and did they have anything in the way that they asked the question that might cause bias? And definitely, did they have anything in the way that they collected their sample that might cause bias? So always think critically about how the data is collected.